Okay, here I am with another method of initial rate problems in order to determine a full rate law. Remember, I'm going to be given data and I'm going to use that data to choose different experiments to develop ratios of the unknown rate law in order to cancel out variables and solve for other variables. So for instance, in this case, reaction number 2 and reaction number 1 both have the NO concentration the same. So if I divide those two, then the variable for NO will cancel out and I'll be able to solve for the variable for H2. So let's do 2 over 1. So the rates are 1.6 times 10 to the negative 7th over 4.0 times 10 to the negative 8th. Remember, always put the larger rate on top. You get whole numbers and that's easier to deal with powers that way. K over K, that's going to cancel. Then I get 1.6 times 10 to the negative 2 over 8.0 times 10 to the negative 3. That's all to the x power. Like I said before, here are my NO concentrations. They're the same, 6.0 times 10 to the negative 3. So that entire quantity to the power of y gets canceled as well. So what I end up with is 4 equals 2 to the x. And so now I have to solve for x. Well, what's x in this case? X equals 2. So now I figured out the order with respect to H2 is 2. So let's do the next one. The next one is one that I'm going to have to cancel out H2 and figure out what's going on with Y for NO. And it looks like 3 and 2 do that. And so if I divide 3 by 2, then I get 3.2 times 10 to the negative 7th and the rate divided by 1.6 times 10 to the negative 7th. K is canceled. Remember that the concentrations of H2 are the same. They're going to cancel. And so I'm left with 1.2 times 10 to the negative 2 divided by 6.0 times 10 to the negative 3, all to the y power. So when I simplify that, what do I get? I get 2 equals 2 to the y. So now I got to figure out what's y. Y equals 1. So now that I've figured out the order with respect to NO, and I knew the order with respect to H2 previously, I can figure out what K is. And so what I just do is I pick one of the experiments, it doesn't matter which one, and I put in everything that I know. In this case, it looks like I picked experiment number 1. That's the rate 4.0 times 10 to the negative 8th. Then I plugged in the data from that experiment, and now I'm going to solve for K. So I get, when I take the square root, when I square 8.0 times 10 to the negative 3, multiply it by 6.0 times 10 to the negative 3, and then divide both sides by that result, I get K equals 0.104 over meters squared times seconds. And so writing out the full rate law, I get rate equals 0.104 molarity to the negative 2 times seconds to the negative 1 times the concentration of H2 to the second power times the concentration of NO to the first power.